Hello dear students, welcome back to online chemistry class. So in our previous video we have seen what is matter, what are the different states of matter and also the general properties of matter. So today we are going to see few experimental studies on the topics that we have already covered in our previous class and also the topic interconversion of matter. So let's get started. First, we are going to see an experimental study which shows that particles of matter have intermolecular attraction. For this, we need a petri dish and also globules of mercury. Now, place the globules of mercury kept at a distance in a petri dish, as you can see in the picture here. Now, shake the petri dish slowly and now you can see that the mercury globules have come together forming a big globule. If you take water instead of mercury here, then also you observe the same result, isn't it? Now, why do you think it has happened? It is because of intermolecular force of attraction. Intermolecular force of attraction is existing between the particles of matter. So with this experiment, we conclude that there is force of attraction that is existing between the particles of matter. Now, let us see an activity to show particles of solids are closely packed and the particles of liquids are less closely packed. For this experiment, we need a measuring cylinder, water, a spatula of sugar, and also a stirrer. Add 100 ml water to the measuring cylinder and add sugar crystals into the water and then stir it carefully. Now what you have obtained is a sugar solution. Now observe the level of water in the measuring cylinder after stirring the sugar solution. What do you observe? We see that the volume of water remains the same, that is at the 100 ml mark. Why do you think it has happened like that? Because the sugar particles fill the intermolecular space that is existing between the molecules of water. And that is why the level of water in the measuring cylinder did not rise. This clearly shows that the particles of solids, that is the sugar crystals that is taken here, are closely packed and particles of liquid, what we used here is water, are less closely packed. Next, let's see an activity to show particles in solids are closely packed and particles in gases are least closely packed. For this, take a round bottom flask as you can see in the picture and add crystals of iodine that is in the solid form. This is a round bottom flask and you can see crystals of iodine at the bottom of the flask. Now, we do not know how many particles are there in iodine crystals that is existing in the solid state. Let's take it as a number x. Now, heat this round bottom flask. What do you observe? We see that the crystals of iodine that was in the solid form, as you can see here, has changed into iodine vapors, as you can see in the picture. And also it has filled the flask completely. Here it is to be noted that iodine vapors also contain the same X number of particles. This means that iodine has only changed its form from one to another. That is, from the solid state, it has got converted into the gaseous state. As you can see here, iodine vapors. So here, the properties of matter has changed, but the composition of matter remains the same. This changing of form from one state to another state is called as interconversion of matter. Let's see that in detail in the coming video. So with this experiment, we conclude that particles of solid, what we have taken here is iodine crystals, are more closely packed, and particles of gas, that is vapors of iodine which we have taken here, are less closely packed, or it is least closely packed compared to that of solids. And that is why vapors of iodine has filled the flask completely.